In this session, we are going to learn about the properties of acids. Also, we study the classification of acids, organic acid, inorganic acid, concentrated acid, etc. And we see what basicity is. So let us study in detail. See these examples of acids. Here we have sulfuric acid, nitric acid, hydrochloric acid, and at the end we have the uric acid here. All these acids are here furnished along with their formula. On what ground, on what basis we identify the given substance as an acid? See this example. I take hydrochloric acid, HCl. HCl, if HCl dissolves in water or an acid dissolves in water, we see it produces two ions, H plus ions and Cl minus ions. But this H plus ion, it has a problem. It doesn't have any independent existence. So immediately, soon after produce this H plus ion, what does it do? This H plus ions combines with the water we have already used here. It combines the water producing H3O plus ions. These H3O plus ions, we term it as hydronium ion. Hydronium ion. H3O plus ions can be called hydronium ion. So we have two products. What are the two products? First one here we got the Cl minus, and second one, the final product, we got hydronium ion or H3O plus ions. So if you write the equation once again, HCl in water, H2O, we get two products. It can be written, it can be remembered as if hydrogen and water. So we get H3O plus and plus this bond between hydrogen and chlorine breaks that we study in the coming classes. H3O plus plus Cl minus. So you got the two product, hydronium ion and chloride ion. The same it is written here. Either you can write these equations in two steps, or you can write as if I have written here in a single reaction. Both are correct. So mind that one. Here HCl in water gives a hydronium ion as well as a chloride ion. So we say, or we term, whichever the substances gives a hydronium ion in water, that substances can be called an acid. So what is an acid? Acid means it gives hydronium ion. It produces hydronium ions in water. So whichever substance is producing hydronium ion in water can be termed as an acid. So now we see the classification of acids. The first classification, the acid acids can be classified into organic or inorganics. Organic acid especially, these acids either found or can be derived from animals or plants. Especially it is found in fruits or in animals or animal products, etc. Say as an example, in tomato, we say oxalic acid is present in tomato. Or we take a tamarind, tartaric acid is present in tamarind. Or we say citric food, citric acid is present there. So organic acid in the sense it means it can be seen or it can be derived or found in plants or in animals. Okay. The same way, inorganic acid means these acids are prepared synthetically or in factories or by chemical reactions. Such acids can be called inorganic acid. It can be also called mineral acid because it is prepared from minerals. Say hydrochloric acid or sulfuric acid. These all are prepared industrially from minerals. Okay. Also here we can say acetic acid, CH3COH, acetic acid. Or we can say formic acid, HCOH. Formic acid is present in ants. The next property of an organic acid is they do not completely ionize, while inorganic acids completely ionize. If you say one example, if you take 1,000 particles, 1,000 particles, not ml, 1,000 particles of acetic acid and 1,000 particles of HCl. And out of this 1,000 particles of acetic acid, maybe 100 or 200 will get ionized to acetate ion, CH3CO minus acetate ion and H plus hydronium ions. Okay, only 100 or 200. While if you take the same 1,000 particles of 1,000 molecules of HCl, Out of the 1000, around 800 or 700 particles will change into H plus ions. That means HCl, sulfuric acid and all giving you maximum larger number of hydronium ions, while these organic acids gives very lesser number of hydronium ion, and rest of these molecules will remain as molecules. Rest of the particles will remain as molecules, as acetic acid or as formic acid. They do not ionize. But here few of them will remain in the molecular form, majority of them will be converted to hydronium ions. Now we see the second category of acids. It is called by strength. Acids can be classified by strength. What was the first one? Acids can be classified whether it is organic acid or the inorganic acid. Now we see strength of an acid strictly depend on what amount of, what concentration of hydronium ions there. So we can say strength of an acid means if it has high concentration of hydronium ions, H3 or plus ions. If large concentration there, we say it is a strong acid, or if there is less concentration of hydronium ions, means the acid is a weak acid. So we know all the organic acids are weak acid. We can say acetic acid, CH3COH, acetic acid, or with carbonic acid, oxalic acid, they are all called the weak acids. Or tartaric acid present in tamarind, they all called weak acids. While at the same time, sulfuric acid, H2SO4, HCl, HNO3, these all are inorganic acids or mineral acids. They have a high concentration of hydronium ion they produce in water. So we say they all are strong acids. The third category of an acid is acid can be classified by concentration. Concentration of an acid means how much particles of acid present in a given aqueous solution. Or if we simply say, if lesser amount of water in an acid, that acid can be called concentrated acid. Or if more amount of water present in an acid, that is called a diluted acid. So here we say less amount of water present. Okay, that means here more amount of particles of acid in this solution. Okay, or here we say large amount of or more water present. Okay, so dilute acid means it consists of or it contains more amount of water, and concentrated acid means it contains less amount of water. Otherwise, it contains more acid particle, and here it contains less acid particles. Now the fourth category is acids can be classified by their molecular arrangement, or what all the elements present in an acid. So we have two types are there. One is called oxy acids and second one is called hydra acids. See this example: HNO3, H2SO4, H3PO4. So here you see an example: HCl, HBr, hydrogen bromide, or hydrogen iodide, HI. See the difference here. Here we have hydrogen along with oxygen there. Here hydrogen and oxygen, of course one more non-metal is there. So mainly we consider hydrogen and oxygen. Here two hydrogen and oxygen, and in phosphoric acid, hydrogen and oxygen. Phosphoric acid, sulfuric acid and nitric acid. But you see here, hydrogen of course there, the both case hydrogen there, but instead of oxygen here, chlorine, hydrogen along with bromine and hydrogen along with iodine. So hydroxide means hydrogen with a non-metal which is not oxygen. Okay, so hydroxide means what? The acid which consists of hydrogen as one of the element, and the second element is not oxygen, but instead of oxygen any other elements can be there. Okay, so hydrogen plus a non-metal other than oxygen. But oxy acids means it is hydrogen plus oxygen. Okay, oxy acid in the sense an acid consists of hydrogen and oxygen are the main constituents. Okay, the fifth classification of acid is classified by their basicity. You see these examples: HCl, H2SO4 and H3PO4. Hydrochloric acid, sulfuric acid, and phosphoric acid. Okay, basicity means how many hydronium ions can be released by an acid in water. Okay, basicity means number of hydronium ions produced. Number of hydronium ions produced. Okay. So you see how many hydronium ions can be produced by HCl in water. So HCl produces H2, 2 hydrogen from water, 1 of acid. So H2 plus 1, H3O. So it will produce H3O plus 1. Okay. So hydrogen loses its 1 electron to chlorine. That we already studied in the chemical bonding. Hydrogen loses 1 electron. So it gets 1 positive charge here. So H3O plus Cl minus. So 1 hydronium ion is produced by hydrochloric acid in water. So 1 hydronium ion there. So we can say HCl is a monobasic acid. Monobasic acid. And if we ask what is the basicity of HCl, since 1 hydronium there, we can say basicity is equal to 1. So it's the same way HCl or HNO3, nitric acid. Both can release 1 hydronium ion in water. So their basicity is 1. So consider sulfuric acid. See how many hydronium ions can be released in water. H2O. So this H2SO4 I write as HHSO4. That means same H2SO4. Okay. For showing the bond breaking, we write as HHSO4. So first step we see the first hydronium produced. That means H3O plus. Okay, H1, H2, H3 and oxygen. H3O plus HSO4. HSO4 minus 1. Here plus 1 minus 1. Okay. So 1 hydronium produced here. Then what happened? Where this HSO4, it is in water. So this HSO4 being a unstable compound, this HSO4 again react with water. It produce the second hydronium ion. The second hydronium ion and sulfate ion. SO4 2 minus. Okay. Now in the solution we have 1 hydronium and the second hydronium. Plus 1 plus 1 plus 2. So making it neutral, minus 2 there. And the solution, there is no HSO4. This HSO4 already got dissociated into hydronium ion. So sulfuric acid producing 2 hydronium ion. So since 2 hydronium ion there, it can be called a dibasic acid. We say dibasic acid. Okay, dibasic acid. So if asked what is the basicity of sulfuric acid, we can say basicity is equal to 2. Okay, basicity of sulfuric acid is 2. See these examples. First one we have already discussed, HCl. It will produce 1 hydronium ion. So the basicity is equal to 1. So it can be called a monobasic acid. Okay. And sulfuric acid, it will produce 2 hydronium ion. So we say basicity 2. So it is a dibasic acid. And in case of phosphoric acid, H3PO4. H3PO4 I have written as H2PO4. Okay. So it will produce first hydronium, second hydronium and the third hydronium. So total we have 3 hydronium ions produced by phosphoric acid H3PO4. So basicity is equal to 3. So since 3 hydronium ion or basicity 3, we say it is a tribasic acid. Tribasic acid. So if 1 hydronium ion released by an acid in aqueous solution, it is monobasic. If 2 hydronium ion by an acid in aqueous solution, it is dibasic acid. Or if 3 hydronium ion by an acid in water is called a tribasic acid. So mind that one, it is not the number of hydrogen atoms, it is the number of hydronium ions. Okay, by the next example we see, it is not the number of hydrogen atom. Hydrogen atom may be more than 1 or 2, but it may be monobasic. Okay, see the acetic acid as an example. It is actually an exception. Okay, can you see the basicity of acetic acid? Since 3 plus 1, 4 hydrogen there, can you say is it a tetrabasic acid or the basicity 4? It doesn't have the basicity 4. Actually, it is a monobasic acid. Why it is monobasic acid? So, it is called acetate radical and CH3CO minus and 1 hydrogen. Okay. While in water, what happened? This hydrogen goes with water produce H3O plus and CH3CO minus. Okay, it produce CH3CO minus. Okay. So we see here only one hydronium ion is produced and another negative ion produced there. Okay, so and this hydrogen atom present this negative ion is not going to be dissociated. So we have only one hydronium ion produced by acetic acid. So we say it is a monobasic acid. And what is the basicity? Basicity is equal to 1. So keep in mind, remember acetic acid is a monobasic acid as it produces one hydronium ion. Don't count it the number of atoms. Always count the number of hydronium ions produced in their aqueous solution. So consider phosphorus acid. Okay, we have already studied phosphoric acid is a tribasic acid, but it is phosphorus acid. Phosphorus acid has such a structure. Okay, but there is a one problem. This hydrogen is not replaceable. It doesn't break from the compound. So how many hydrogens are replaceable? How many can be replaced? Here 1 and here 2, the second hydrogen. 2 hydrogens are there which can be replaced. So 2 hydrogens can be replaced from this acid molecule. So it produces with 2 hydronium ions with water. So since 2 hydronium ions are produced, we say phosphorus acid is a dibasic acid. So remember, while phosphoric is tribasic and it is phosphorus. Phosphorus acid is dibasic. Hope this video was helpful to make you understand the types of acids and their basicity, etc. And if you like this video, please subscribe our channel.